This presentation is about subtractors. We will explore binary subtraction circuits, including the implementation of half subtractors and full subtractors. Let's begin with the basic rules of binary subtraction. 0 minus 0 equals 0. 1 minus 0 equals 1. 1 minus 1 equals 0. And 0 minus 1 equals 1 but requires a borrow. For example, 101 minus 011 equals 010. Now let's discuss the half subtractor. A half subtractor is a combinational circuit that performs subtraction of two single bits. It produces two outputs, the difference and the borrow. Note that it does not consider any previous borrow input. The inputs to a half subtractor are A, which is the minuend, and B, which is the subtrahend. The outputs are D for difference and B0 for borrow. Let's examine the truth table for a half subtractor. When both inputs A and B are 0, the difference D is 0 and the borrow B0 is also 0. When A is 0 and B is 1, the difference D is 1 and the borrow B0 is 1. When A is 1 and B is 0, the difference D is 1 and the borrow B0 is 0. Finally, when both A and B are 1, the difference D is 0 and the borrow B0 is 0. The corresponding Boolean expressions for the half subtractor are as follows. D equals a XOR B, and B0 equals a bar in B. Now let's look at a circuit implementation of the half subtractor. It consists of one XOR gate and one AND gate along with a NOT gate. The inputs A and B are fed into the XOR gate, which produces the difference output D. Input A is also fed into a NOT gate, and its output is fed along with input B into an AND gate to produce the borrow output B0. Now let's discuss the full subtractor. A full subtractor is a combinational circuit that performs subtraction of 3 bits. It considers the previous borrow from the lower significant bit. It is essential for multi-bit binary subtraction. The key difference between a half subtractor and a full subtractor is that the full subtractor includes a borrow input, often denoted as B in. The inputs to the full subtractor are A, B, and B in, which is the previous borrow. The outputs are D for difference and B out for borrow out. Here's the truth table for a full subtractor. The full subtractor has 3 inputs, A, B, and B in, and 2 outputs, D the difference and B out the borrow out. Boolean expressions for the full subtractor are D equals a XOR B in, and B out equals a bar and B plus a bar and B in plus B and B in. Here is one way to implement a full subtractor circuit. A full subtractor can be implemented using 2 half subtractors and 1 OR gate. The inputs A and B are fed into the first half subtractor. The difference output from the first half subtractor and the B and input are fed into the second half subtractor. The difference output from the second half subtractor is the final difference output D. The borrow outputs from the 2 half subtractors are fed into an OR gate, and the output of the OR gate is the final borrow out B out. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.